Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2020 paper 1. In this lesson, we will discuss 4 different topics. Means we will discuss past paper questions from 4 different topics. We will talk about questions from measurements, kinematics, forces and momentum. And these topics are very important because first 10 questions are from these topics. So clear understanding of these topics is very important to get good score in paper 1. So in today's class, we will discuss these topics in detail and hopefully you will improve your understanding of these topics. So watch video carefully and try to improve your conceptual understanding. If you have any questions, you can leave in comments and I will answer your questions as soon as possible. Let's study physics together. Let's improve together. In today's class, we are talking about paper 1 from October-November 2020. Total time for this exam is 1 hour and 15 minutes and there are 40 questions on this paper. You need to answer all of them and total mark for this paper is 40. On second page of your exam paper, you can find values of some constants and maybe you will need these values for some calculations in paper 1. So if you need value of any constant, you can come back to second page and you can check this page for value of any constant. On next page of your exam paper, you can also find some formulae, some important formulae for AS and A2 physics. So let me highlight first of all the formulae you need for AS physics. So these two formulae you need for AS physics. And the next one you also need for AS physics when you need to calculate work done by a gas. Then this formula is only true if P is constant at constant pressure. So very important point. So let me write down. This one is only used when P is constant, so for constant pressure. And this formula is only used if A is constant, means A is uniform. Otherwise, you cannot use these two formulas. If you go to next one, this formula you also need for AS physics. And the next one is for Doppler effect. And this one you also need for AS physics. If you go to next, you need this one for AS physics. You also need these two for AS physics. That's all what you need for AS physics. So these formulae are very basic but very important. For question number 1, it is given to us what is a reasonable estimate of the volume of a fully inflated standard football. So we need to estimate the volume of a football. So first thing you need to imagine that how big can be the volume of a football. And volume of football can be this big. And you need to imagine that how big is this. And this can be about 20 to 25 centimeters. Means this is the diameter of football. Means the diameter of the football, we can simply imagine that it can be about 20 to 25 centimeters. Or simply you can understand is equal to the diameter of head. So very simple way to imagine. So it is equal to diameter of your head. You can estimate. You can use meter rule. You can measure that one. And that is about 20 to 25 centimeters. In order to find volume of football, we need to imagine shape of football. And shape of football is spherical. So it simply means that we need to find volume of sphere. So we can write down volume of football. This will be equal to 4 by 3 pi r cube. Radius of football we will take only 12. Means it can be from 20 to 25 centimeter. This is diameter of football. Radius means half of diameter and we need to take cube of that. Let's calculate now and find the volume of football. First of all, we have 4 divided by 3. We have to multiply this one with pi, so 3.142, and we need to multiply with cube of 12. So we have cube of 12. Now if we just calculate, our final answer is this. So this is volume of football. So simply we can write down this is equal to 7,239.2 cubic centimeters, or we can say centimeter cube. So the closest answer is this one, 6,000 centimeter cube. So this is the best possible option for this question. For the second second question, we need to find out what is not an SI base unit. First of all, let's try to write down quantities of given units. Coulomb is unit of charge. Charge is quantity, but Coulomb is unit. Kelvin. Kelvin is unit of temperature, so we can write down temperature here. Kilogram is unit of mass, and second is unit of time. Now we need to find out which units are SI units and which unit is not SI base unit. If you look at time, means second, this is SI base unit. Kilogram, this is also SI base units. Kelvin, this is SI base units. But Coulomb is not SI base unit. So our answer for this question is A. Current as unit ampere, and ampere, this is SI base unit. But charge is not SI base unit. So we need to understand the difference between charge and current. For this question, we need to find out which two quantities are both vector quantities. So first of all, let's write down what is vector quantity. A vector quantity has magnitude and also direction. So this is the difference between vector and scalar. So these are properties of vector, simply we can say. If you look at option A, displacement. Displacement is vector, but distance, this is scalar. So this is not right option. If you go to second one, force is vector, momentum is also vector. So this is our possible answer. But if you go to C, torque is vector, time is scalar, weight is vector, but pressure is scalar. Actually is a tensor, but that is not part of our syllabus. So simply we assume this one is scalar. So the answer for this question is B. For question number 4, it is given to us a calibration curve is shown for an ammeter whose scale is inaccurate. So it simply means that we have faulty ammeter. So we can write down here, first of all, we have faulty ammeter. Then the reading on ammeter is given on y-axis. So these are the readings on ammeter. But if you look at x-axis, we have value of current. And this current is actual value of current. So we can say this is actual. It is also given to us two readings are taken on the meter at different times during an experiment. And readings are this one. So we have two readings on ammeter. By how much did the current really increase between taking the two readings? So first of all, we can write down given two readings. If you look at this one, I have already written here 0.47 milliamps. So this is 0.47 milliamps. Means this is the reading on faulty ammeter. So we can write down here 0.47. And the first reading we have that was 0.13. Now we need to find out the actual current. So we can write down here actual current. So simply we can write down here actual current. And values of actual current we can find out from x-axis. So this is value of actual current when faulty ammeter is reading 0.13. At that time, actual current is 0.14 milliamps. And when faulty ammeter is reading 0.47, actual current is this one, 0.44. So we can write down this is actual 0.44 milliamps. We need to find how much it increased, means how much it increased from here to here when faulty ammeter is showing these two readings. So simply we need to find the difference. We can say delta I. So delta I in this case is 0.44 minus 0.14. And this is equal to 0.30 milliamps. And this is our final answer. So the answer for this question is A. For question number 5, we need to calculate the percentage uncertainty in calculated value of G. But for this question, equation for time period is given and measurements are also given. Means the value of L and its absolute uncertainty is given, time period is given with its absolute uncertainty. We need to calculate percentage uncertainty in G. First of all, we need to rearrange this equation. If we take square on both sides, we can write down T square is equal to 4 pi square times L divided by G. Now we can rearrange this one. We can write down G times T square. This is equal to 4 pi square times L. We need to calculate percentage uncertainty in G. So we can place G on one side. So we can write down this is 4 pi square L divided by T square. We need to calculate percentage uncertainty in G. So we can write down delta G divided by G percentage uncertainty. This has to be equal to delta L by L plus T has power 2, so we have to multiply with 2. So this has to be delta T by T. We need to calculate percentage uncertainty, so we have to multiply this one by 100. Now simply we need to plug in values. Delta L means the absolute uncertainty. This one is delta L, and this quantity is delta T. Now if we plug in values, we have 0.2 divided by 87.3 plus 2 times we have 0.05 divided by 1.9, and we have to multiply this one by 100. If we do this calculation, our final answer will be 5.49%. So it simply means that 5.49 is equal to 5.5. When quantities are multiplied or quantities are divided, percentage uncertainties are added. So this is the main concept you need to understand from this question. For question number 6, it is given to us an object moves in a straight line. The graph shows the variation with time t of the velocity v of the object. At time t is equal to 0, the object is at point x. What is the displacement of the object from point x at time t is equal to 0.80 seconds? Let's say this point is x, this point is y, and let's say this point is z. First thing we need to understand is that between x and y, velocity is negative. So between x and y, velocity is negative. And between y and z, velocity is positive. So this is a very important point. So it simply means that at point y, object is changing direction. Means direction of velocity is changing at point y. So let's try to see in a different way. Let's say this is point x, object is moving first of all to the left between x and y, and then between y and z, object is moving in opposite direction. So this is point z. In this case, we will take to the right positive. So if we take to the right positive, so this displacement will be negative. So this is negative displacement and this one is positive displacement. If we will add these two displacements, we can find the total displacement. Now first of all, let's try to find out the displacement between x and y. If we find displacement between x and y, that is equal to the area between this line and x-axis. So simply this is triangle. We can write down this is 1/2. Time in this case is equal to 0.2 and velocity is equal to 2. If we solve this one, our final answer is negative 0.2 meters. We are taking this negative because this is to the left. Now let's move on to next one. We need to calculate displacement between y and z. In order to calculate displacement between y and z, simply we need to calculate this area. In order to calculate this area, this is also triangle. So 1/2, we have to take value of time between these 2 points. So we have 0.8 minus 0.2. We have to multiply this one with velocity. Velocity changes from 0 to 6. So simply we can say this is x. If we multiply this one, our final answer is 1.8 meters. We need to calculate the total displacement now. In order to calculate total displacement, simply we need to add these two displacements. So we have dxy plus we have dyz. Dxy is minus 0.2 and dyz, this is plus 1.8. So our final answer will be 1.6 meters. So the answer for this question is 1.6 meters. So this is how we can calculate. Displacement is a vector quantity, so we have to consider direction as well. For question number 7, it is given to us an object accelerates uniformly from rest to speed v. It then moves at constant speed v for a time of 8.0 seconds before decelerating decelerating uniformly to rest. The total time taken is 12.0 seconds and the total distance traveled is 60 meters. We need to calculate what is the value of v. In this question, it is given to us, first of all, object accelerate. So we can write down here, first of all, object is accelerating. Then object has constant speed. Object has constant speed. And then object decelerate. We can write down object is decelerating. So it has three different kinds of motion. So the best way to answer this problem is by sketching. So we will sketch velocity time graph so we can see a clear picture of this, and then we can do some calculations to find value of v. So we have v on y-axis and we have time on x-axis. First of all, object accelerates. So this is stage 1. Object is accelerating and the maximum speed is v. Then object moves at constant speed. So this is constant speed. And then object decelerate with uniform deceleration. Acceleration and deceleration, they have the same value. So that is very important point. So we can divide this one into three different parts. It is given to us when the object is moving at constant speed, time taken is equal to 8.0 seconds. And let's say the time taken when object is accelerating from rest, that time is equal to t1. And the time taken when object is decelerating to rest, let's say that time is equal to t2. In this case, total time we have, so we can write down here, total time is given, that is equal to 12.0 seconds. So we can also say that total time is equal to t1 plus t2 plus 8.0, and this is equal to 12. So from here we can get value of t1 plus t2, that will be equal to 4.0 seconds. We need to understand area under this graph is equal to distance, and total distance is given to us. We can say total distance. Total distance is equal to distance traveled in 8 seconds. Distance traveled means distance in 8 seconds plus distance traveled in t1 plus distance traveled in t2. Distance traveled in t2. Now we can write down the equation. For the first stage, we can simply write down this is 1/2 times v times t1. For the second stage, we can write down this is 8 times t. And for the last stage, we can write down this is 1/2 v times t2. So we can place these two together, 1/2 v t1 plus we have 1/2 v t2 plus we have 8t. Now from here we can take 1/2 v common. So I will be writing here. If we take from here 1/2 and v common, we can say 1/2 v, this is common. So here we left with t1 plus t2 plus we have 8 times v. So this is v actually. So this one is 8 times v. So this is not t. This one is v. So this is 8v. Now in this case, we have t1 plus t2, that is equal to 4. So we have v times 4 plus we have 8v. So 4 divided by 2, it means we left with 2 and here is 8. So this is equal to 10v. And that is equal to 60. So we have 60, that is equal to 10v. So from here we can find value of v, that is equal to 6.0 meters per second. So our answer for this question is C. This is how you can calculate value of v. There is minor typo in this question. Let me correct this one. This one has to be 8v as well. So this one is also 8v. See you in next video. Bye for now. Welcome to A-Level and AP Physics. In today's lesson, we will talk about past paper questions on mechanics from October-November 2020, paper 1. In this lesson, we will talk about questions from different topics. We will talk about questions from forces, momentum, work, and power. And these topics are very important for paper 1. So let's study together. Let's improve together. In the last class, we have discussed from question number 1 to question number 7. And the solution of those questions you can find lesson in Mechanics Part 01. Today's class we will start from question number 8. For question number 8, it is given to us a device for spraying paint consists of a box with its axis horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. For this question, it is given to us paint is fed into the box. So this one is the box and this one is the tube. So the paint is fed into the box via this tube and the paint is coming out of the box. So this is direction of paint. Paint is coming out. So when the paint is coming out, it means there is a force on the paint. So simply we can say there is force on the paint and this force is by the box. So there is force on paint. There is force on the paint and there is also reaction force on the box. And in this case, action and reaction, these two forces have to be equal in magnitude, but these two forces will be opposite in direction. For this question, it is also given to us the paint is ejected at a speed of 2.5 meters per second, and there are 400 holes in this box. Cross-sectional area of each hole is given, that is equal to 0.4 millimeter square. Density of the paint is also given. We need to find out what is the horizontal force required to hold the device stationary as it ejects the paint. We need to hold this device stationary. So as the paint, imagine that go in this direction, box will go in the opposite direction. So we need to hold box stationary. So we need to apply force in opposite direction of force on box. So in this case, simply we can say the force on box, this is equal in magnitude to force on paint. So these two forces are equal in magnitude but opposite in direction. So when the paint go this way, box will go in opposite direction. We need to hold box stationary. So we need to apply force in direction of paint to hold this one stationary. So simply we need to find out force on paint. Force on paint simply equal to change in momentum. So this is the net force on the paint. That is equal to delta P over delta T. In this case, initial momentum along horizontal was 0. So the final momentum along horizontal also has to be 0. So that's the reason these two forces are equal. Most of the time, many students, they can answer this type of questions because this question is kind of typical question and you will see this one in many past papers. But most of the time, students, they don't get the actual concept behind this question, and that is conservation of momentum. Momentum along horizontal is conserved. So the net force we can find out net force on the paint, and net force on the paint is equal to the force we need to apply on the box to hold it stationary. So that is equal to delta P over delta T. Delta P over delta T, this is equal to delta M times V over delta T. In this case, initial velocity of the paint is 0. So the change in velocity of the paint, that is equal to V. So we can say V times delta M over delta T. Now we need to find out change in mass over time. So change in mass, simply we can write down this is speed and the mass is equal to density times change in volume over time. Change in volume over time. In this case, density of the paint is constant and speed of the paint is also constant. So simply we can take these two quantities out. Then we left with change in volume of paint over time. Now we need to find out change in volume over time. Imagine that we have one small cylinder and this cylinder is like a hole. So we are talking about hole. The shape of the hole is like a cylinder and cross-sectional area of this hole, imagine that is A, and the length of this cylinder is equal to X. Speed of paint is also given. V of the paint is given, that is constant, and that is equal to 2.5 meters per second. We need to find out delta V over delta t. Delta V is the volume, change in volume. That one will be equal to A times X. This is the change in volume over we have this is change in time. Now from here simply we can say X over delta T. This is equal to A times V. So delta V over delta T is equal to A times V. So delta V over delta T is equal to A times V. Now we can plug in these values. So we have V here and delta V over delta T, this is equal to A times V. So simply we can say in this case force on the paint means force on the paint is equal to A times rho times V square. Cross sectional area is given to us, that is equal to 0.4 millimeter square, means 10 to negative 6. Density is given, that is equal to 900, and the speed of the paint is given, that is 2.5 square of speed. Now if we multiply this one, we can find out force on paint, that will be equal to 0.90 newtons. But one thing we are missing, we have to multiply with 400 as well, because we have 400 holes. So the final answer, if you multiply this one, you will get is equal to 0.90 newtons. So the final answer for this question is B. This is how we can approach this kind of problems. So the resultant force on the paint is equal to rate of change of momentum of paint. Let's move on to question 9. Question 9 is quite simple if your concept is clear. But if your concept is not clear about acceleration, deceleration, and speed, then this question is very tricky one. Let's try to understand first of all what is given to us for this question. For this question, simply it is given to us, we have a balloon. So simply you can imagine that we have this balloon and we drop this balloon in stationary, in still air, means we cannot ignore effects of air resistance. So you can imagine that these are air particles. So if we look at this one initially, if we look at this balloon initially, if we draw the forces acting on this one, initially there is only one force acting on this, that is equal to mg. So the net force in this case, we can also say net force is equal to mg. Net force is equal to ma, so we can say ma is equal to mg. So from here we can say a is equal to g. So mass is cancelled with this mass. So initially the net force on balloon is downwards and it has net acceleration downwards, that is equal to g, means a is equal to g. But when this balloon will start moving, there will be air resistance and air resistance will act upwards. Why air resistance? Because balloon will hit. So imagine that this is balloon and my hand is air particle. Balloon will hit air particle and air particle will hit back on balloon in opposite direction. So there will be force on balloon in upward direction. So this is air resistance, and here we have weight. As the speed of the balloon will increase, as balloon is accelerating, it simply means that speed of the balloon is increasing. As speed increase, air resistance will also increase. Finally, these two forces, they will balance each other. So we will say W will be equal to FA. So air resistance. So these two forces, they will be balanced. When W is equal to Fa, it simply means that net force on balloon is equal to 0. If net force 0, it means acceleration of balloon will be equal to 0. If acceleration is equal to 0, we call balloon has reached terminal velocity. Terminal velocity. So simply we can say terminal velocity. Or simply you can say balloon has reached maximum constant speed. So we can say constant speed. Now if you look at motion of this balloon, initially balloon is accelerating. Initially balloon is accelerating, but acceleration is decreasing with time, and finally acceleration is equal to 0. Acceleration is decreasing, it does not mean that it is decelerating. So very important point and often misunderstood. If acceleration is decreasing, it doesn't mean that balloon is decelerating. When amount of acceleration is decreasing, it means balloon is still speeding up. Speed of the balloon is still increasing. So we will say balloon still speed up. When acceleration is decreasing, balloon still has acceleration. If balloon has acceleration, it means speed of the balloon is increasing. So it means speed of the balloon is increasing. When acceleration is zero, it means speed of the balloon is constant speed. And these are the points we need to understand to answer this question. Now, if you look at option A, decelerate, not, this is wrong. This is incorrect. So this is incorrect option. Balloon falls at constant speed, incorrect. Balloon accelerate. Decelerate, incorrect. Falls at constant speed, incorrect. The last option, accelerate, then constant speed. And this one is right option. So the answer is D. D is the right answer. Very important concept you need to understand. If acceleration decrease, it doesn't mean that speed is decreasing. It means body is still speeding up, but the rate of increase of speed is decreasing. If we sketch graph for this one, we can see the shape of the graph. If we take V on y-axis and we take T on x-axis. So in this case, acceleration of the balloon is decreasing. It means the gradient of this curve will decrease, and finally it is horizontal. It has reached maximum speed. So this is what is happening, and this one is called VT, terminal velocity. For question number 10, it is given to us an object of mass small m traveling with speed 5u collides with and sticks to an object of mass 5m traveling in the same direction with speed u, as you can see in this figure. We need to calculate the speed, means the combined speed of two objects. So first of all, let's try to sketch this one, what is happening in this case. This is what is happening before collision. So simply we can say this is what is happening before, and now we need to sketch what is happening after they collide, after collision. So after collision, we will see these two objects stick together. So this one is mass m and this one is 5m. We need to calculate the combined speed, means we need to find out value of v. One thing we need to understand, initial momentum is to the right, so the final momentum also will be to the right. So in this case, we need to take one direction as positive. So I will be taking in this case to the right as positive because momentum is to the right. So if we write down momentum before, means the total momentum, or we can say initial momentum, total initial momentum, it has to be equal to total final momentum. We have two bodies, so the first one has mass m and the speed of the first object is 5u, and the speed is positive because it is moving to the right. And if you look at the momentum of the second object, the mass of second object is 5m and the speed of this one is positive because it is moving to the right, and we have taken to the right as positive. Now we need to look at momentum of this object. The total mass of these two objects is m times 5m times v. So if we simplify, this one will be equal to 5mu and this is also equal to 5mu. So here we have 6mv. We need to calculate v. So this is equal to 10mu and this is equal to 6mv. So we can cancel m with m. So v finally, this will be equal to 10 divided by 6 times u, and this is final speed of those two objects. I mean, this is the combined speed of these two objects, and this is what question is asking us to calculate. So the answer for this question is 10 by 6. For question number 11, it is given to us an air bubble is rising through a liquid at a constant speed. The forces on air bubble are upthrust, viscous drag force, and its weight. We need to find out which diagram shows directions and relative sizes of the forces. So first of all, let's try to compare magnitude of forces acting on air bubble. If you look at weight of air bubble. Weight of air bubble will be equal to its mass times g. So simply we can say it is equal to mass of bubble times g. But mass of bubble we can also write down in terms of its density. That will be equal to density of air times volume of air bubble times g. In this case, air bubble is inside the liquid. So here we have liquid and air bubble is inside this liquid. This is telling us that volume of the air bubble is equal to volume of liquid displaced. So we can say volume of liquid displaced. So volume of air bubble is equal to volume of liquid displaced. Now we can write down upthrust. Upthrust is equal to weight of fluid displaced, means weight of liquid displaced. So we can write down weight of liquid displaced. So here we have weight of liquid displaced. And weight of liquid displaced is equal to density of liquid itself. So we can say density of liquid times volume displaced. In this case, volume displaced is equal to volume of bubble times g. Now if we compare these forces, we can say V is the same, G is the same. As density of liquid is much greater than density of air. It means that upthrust is much greater than W. Means U is much greater than W. So this is one thing now we understand. U has to be much greater than W. Now if we look at option 4, this one is wrong, because in this case weight is greater than upthrust. So this one is wrong. This is one thing we can say, this one is wrong. Now next thing we need to understand is direction of forces acting on air bubble. So if we talk about direction of forces, in this case it is given to us that bubble is rising. So bubble is moving up, means the speed of the bubble is up. As speed of bubble is up, weight is acting down. Always weight is acting down. And upthrust, direction of upthrust is always up. So this is direction of upthrust. Now bubble is rising, so drag force has to act downward. So we can say this is drag force. So these are direction of forces. Now if you look at option C is also not possible because W is close to upthrust. So this is also not possible. If we go to option B now, as bubble is moving at constant speed, so it simply means that F net on the bubble is equal to 0. Means upward forces are equal to downward forces. We can say upward net force has to be equal to downward force. Means upward forces are equal to downward forces. So this is not true because the sum of these two is not equal to this. So option B is also not possible. So the best answer for this question is, means the best possible option is A for this question. For question number 12, it is given to us a couple applies a clockwise torque of 9.0 newtons meter to a circular disc. Which diagram shows this couple? If you look at option A, we can calculate torque of a couple. In this case, torque will be equal to one force times the perpendicular distance between two forces. So we have force 9.0, we have to multiply with perpendicular distance. That is equal to 0.5 meters. In this case, value of torque is equal to 4.5 newtons meter. And this one is clockwise. So torque in this case is clockwise. But this is not right option. I mean, this is not correct. Torque has to be equal to 9.0. So this is not possible answer. Now, if we go to option C, for option C, we can also calculate torque. Torque here will be equal to 45 newtons times the perpendicular distance between these two forces, that is equal to 0.10 meter. And this answer is also equal to 4.5 newtons meter. But this torque is, this is the pivot you can imagine. This is counterclockwise, meaning this is anti-clockwise. So this is also not correct answer. So this is also not possible answer. If you look at option B, in this case we can calculate torque of couple. In this case we have force 45 newtons and the distance between forces is equal to 20 centimeters. It means 0.20. If we multiply this one, our answer will be 9.0 newtons meter. And this torque is clockwise. clockwise. This is what question was asking us to calculate. This is 9.0 and this is clockwise, so this is right answer. If you look at option D, we can also calculate torque due to this couple. Force we have 9.0 and the distance between forces is equal to 1.0 meter. So this is equal to 9.0 Newton meter as well. But if you look at direction of torque in this case is anti-clockwise. So this one is anti-clockwise and this is not right answer. I mean, this is incorrect because torque has to be clockwise. So this is not right answer. So the answer for this question is B. For question number 13, it is given to us a shelf PQ is attached to a vertical wall at P and supports a book. The shelf is held horizontal by a rigid bar XY as shown in figure. So we have shelf. So this one is shelf. It is attached with wall at point P and a book is placed on shelf. There is a rigid bar attached at this point. Weight of the shelf is WS. This is weight of shelf and weight of the book is WB. The bar is at an angle theta to the shelf and exerts a force F on the shelf. The shelf is in equilibrium. So we need to understand what does it mean by equilibrium. Equilibrium means that some of the forces acting on the shelf are equal to 0 and the sum of the torque acting on this shelf is also 0. So these are two basic conditions for equilibrium. Now for this question, we need to find out what are the magnitudes of the horizontal and vertical components of the force of the wall on the shelf at P. Force of the wall on the shelf at P. Means we need to find out forces acting at this point. Force of the wall means force by this wall on this shelf. We have to find component of that force. Now the best way to answer this question is, first of all, we can draw the line here. So from this point we can draw a line. This is telling us force acting on the shelf, because for this question it is given to us F is the force on the shelf. So F is force on the shelf. So this is the force on shelf. We can say this is force F. This force is the force acting on the shelf by the bar, and this force is given here. In the question it was given to us, and in the question they have drawn this force here. We have simply redrawn this force here to get clear picture of this question. Now we need to find out what is value of this angle. So simply we have to find out value of this angle. If you look at this angle and if I draw horizontal line here, this angle also has to be theta. It simply means that F is making angle theta with horizontal. So this is angle theta and this angle is given in question. Or simply you can say alternate angles are equal. Now we can resolve this one into components. So we can resolve into two components. One is horizontal, one is vertical. So horizontal component will be equal to F cosine of theta and vertical component will be F sine of theta. Now we need to look at forces. If we look at along horizontal, there is only one force that is acting on the shelf, and this force is acting to the right. So there must be a force by the wall on the shelf to the left. So there must be a force acting on the shelf by the wall. Then that force we can say Fpx. And that force has to be equal to F cosine of theta, because this shelf is in equilibrium. So forces along horizontal also has to be equal. We know net force along horizontal. So that's the reason we can say Fpx is equal to F cosine theta, but this is in opposite direction. Now we need to look at forces in vertical direction. So we can look at forces in vertical. In vertical, if we look at forces, we have one force F sine of theta that is acting upwards. So we have this force that is acting upwards, and we have WB that is acting down, and we have WS that is also acting down. We need to find out force acting at this point. So this force has to be vertically upwards, and we can say this force is FPY along vertical. So we can write down here FPY. We need to find out this force. So FPY from here we can write write down, this will be equal to Ws plus Wb minus f sine of theta. So this is value of Fpy, magnitude of Fpy. Now if you look at given options, horizontal component has to be equal to f cosine theta. So this is horizontal component. So it means option C is not possible. So this is not possible. This is also not possible. So the answer is A. Our answer is A. A is not possible answer because this is telling us f cosine theta. So this is not possible. So the best possible answer for this question is B. So B is the right answer. We can also, when we have find value of f px, we can come back and we can figure out from here, because f minus f cosine theta is not possible. So it has to be f sine theta because we are talking about forces along vertical. So we can find over final answer. Otherwise, you can compare forces like this. Upward forces has to be equal to downward forces, and you can find out Fpy. Question number 14. For question number 14, it is given to us a glider is descending at constant speed at an angle of 15 degrees to the horizontal. The diagram shows directions of lift L, A resistance R, and weight acting on the glider. We need to find out which vector triangle could represent the forces acting on the glider. First thing we need to understand constant speed. So constant speed means that F net on this glider is equal to 0. If F net is equal to 0, it means it should form a closed triangle. It should form a closed triangle. So this is first thing we need to understand. If there are forces more than 3, then it should form a closed polygon. In this case, it has to form closed triangle. But if you get all these options, they form a closed triangle. So this first point is true for all of them. Now the second thing we need to find out, we need to look at direction of forces. If you look at direction of weight, so this is right, that weight is acting down, weight is acting down, weight is acting down, weight is acting down. So this is W. So this one is right. Direction of weight is right. Now if you look at direction of L, so L is acting, you can see from here if we draw this one. So L is inclined to the left. So now if you look at this one, in this case you see this one is L. So this is inclined down. It has to incline this way, but it is inclined down below horizontal. So this one is wrong. So this L is wrong. We will look at R later. So this one is R. We will look at this one later. Now if you look at L here, in this case you can see, so this is L. So this is inclined to the left. So this one is right. Now if you go to option C, in option C you can see L. So this is L. This is inclined to the right. So this one is wrong. Direction is wrong. Now if you look at this one, so this is inclined to the left from vertical. So this one is right. Now the last one we have resistance force. If you look at this one, this value, you can see this is making angle 15 degrees with the horizontal, but this angle is more than 15 degrees. So this one is wrong. So it means option A is not possible. Now if you look at option B, for option B you see it is making angle 15 degrees above horizontal, but this is making angle below horizontal. So this one is wrong. So A is not possible answer, B is also not possible answer. If you look at C, C is not possible answer because direction of L is wrong. If you look at direction of R, this is also wrong. Direction of R is also wrong. So only option we left is D. So D is the right answer. If you look at direction of R, you can see this is making angle above horizontal. So this one is the right answer. So like this, how you can figure out and you can find the right answer. This question is a repeated question. If you check October-November 2014 paper 1-1 question 10, you can find this question there. For question number 15, it is given to us a solid cylinder of density rho c, cross-sectional area A, and length x is submerged in a liquid of density rho L. The upper face of the cylinder is at a depth h, capital H, below the surface of the liquid as shown in figure. The acceleration of free fall is g. We need to find out which expression gives the magnitude magnitude of the upthrust acting on the cylinder. We can find out upthrust using different methods. First of all, let me explain to you upthrust using a straightforward method. Upthrust is equal to weight of fluid displaced. So we can say upthrust on any object is equal to weight of fluid displaced. So we can simply write down weight of fluid displaced. And weight of fluid displaced is equal to density of the fluid. Density of fluid means liquid or gas, time volume displaced means volume of fluid displaced. So we can say FD, volume of fluid displaced, times G. So density of the fluid. Density of the fluid in this case is given, that is equal to rho times L. And volume of fluid displaced is equal to volume of this cylinder. And volume of this cylinder is equal to A times X times G. So we can simply write down upthrust is equal to rho L times A times X times G. So the answer for this question is D. So D is the right answer. But you can also calculate upthrust using a little different method. Upthrust is equal to delta P times A. Delta P time cross-sectional area. So what is delta P? It means the difference in pressure. If we take P1 at this point, let's say we take P2 at this point, liquid pressure. So we can say P2 minus P1, this one will be equal to delta P. P2 in this case will be equal to rho G H plus X. So this is minus, we have rho G capital H times A. Now we can simplify this. We can say this is rho G H plus we have rho G X, we have minus rho G H, and this is multiplied by A. We can cancel rho gh with rho gh. So simply we left with rho, this is density of liquid, rho gx times A. So if we rearrange this one, this will be equal to rho L x A times G. So the answer is this one. So you need to understand, often we understand that P, pressure due to liquid, is equal to rho gh. But this rho is the density of fluid. So you have to be very clear about this one. So in this formula, P is equal to rho gh, and in this formula, rho is density of liquid. So this is the point they are testing. They are trying to check your understanding of this. So is this density of liquid, or this is density of object itself? This is density of liquid. That's the reason we have written here rho L. So this is density of liquid. Density of liquid. Let me emphasize on this formula again. P is equal to rho GH. This rho is density of liquid. So we can say this is density of liquid, or simply you can say this is density of fluid. And this H, this is the depth. So you need to understand this is depth. And P is the pressure. So this is. So you have to be very clear about this one. What is this rho? This is density of fluid. For question number 16, it is given to us a ball drops on a horizontal surface and bounces elastically. Elastically simply means that there is no change in kinetic energy before collision and after. Means kinetic energy of the ball before collision is equal to kinetic energy of the ball after colliding with the surface. So simply in this case, we can also write down kinetic energy initial is equal to kinetic energy final. Kinetic energy before collision is equal to kinetic energy after collision. But question is asking us what happens to the kinetic energy of the ball during very short time that it is in contact with the surface. So when the ball is in contact with the surface, speed of the ball is zero. Speed of the ball is zero, means ball has no speed. As the speed of the ball is zero, it simply means that kinetic energy of the ball is also zero. Now we need to find out what actually is happening. Imagine that we have a ball, and this ball drop from certain height, it will hit this ground. It will hit the surface. When the ball will hit the surface, you can imagine that, let's say this is the ball. This, my hand, upper hand is a ball and the lower hand is the surface. So ball is coming down like this. When it will touch the surface, ball will expand. Mean the shape of the ball will change. So ball will deform. And then this ball will gain shape again and rise up. So ball will go down, its shape will change, it will deform because there is a force on the ball in upward direction, and then ball will gain shape again and ball will go up. So this is what is happening. So at this point, the shape of the ball will change. So the shape of the ball will be like this. So when shape of the ball change, in this process, kinetic energy of the ball, that will be converted into elastic potential energy of the ball, because at this point ball is not moving. Now in this case, there is a resultant force on the ball. So finally this ball will change direction and it will rise to the same height. So kinetic energy before collision and after will be the same, but kinetic energy when it is in contact with the surface will be zero. So in this case, kinetic energy will be converted into elastic potential energy of the ball. So this is the point you need to understand. Now let's try to find out the best possible option. Most of the kinetic energy is lost. No, this is wrong. This is elastic collision to heat and sound. This one is wrong. The kinetic energy decreases to zero and then returns to its original value. First of all, kinetic energy will be converted into elastic potential energy. Then again, this will be converted back into kinetic energy. So B is possible option. Kinetic energy remains constant because it is an elastic collision. This one is wrong. We are talking about when the ball is in contact. So that time ball is not moving. Option D, kinetic energy remains constant in magnitude but changes direction. This is wrong. Kinetic energy is a scalar quantity. It has no direction. So this option is also wrong. So the option A is also wrong. So the best possible answer for this question is B. Tricky question, but very important to have better understanding about kinetic energy and elastic potential. Very nice question on this topic. For question number 17, it is given to us some gas in a cylinder is supplied with thermal energy Q. Supplied means this is the input energy. The gas does useful work in expanding at constant pressure from volume V0 to volume Vf, as shown in figure. We need to calculate efficiency of this process. So efficiency simply is equal to useful energy output, we can say useful energy output divided by total input energy. In this case, useful energy out is the work done by gas. Useful work done by gas. So we can say W by gas divided by thermal energy. So we can say thermal energy. This is the energy input divided by thermal energy. And thermal energy in this case is given is equal to Q. So we can write down thermal energy is equal to Q. Work done by gas is equal to P times delta V. Work done by gas. So we can write down this one. P times V final minus, this is the change in volume. Gas is expanding. So the V final is greater. V final minus V initial divided by energy supplied means thermal energy. So the answer for this question is C. Very straightforward question. Simply you need to understand work done by gas. For question number 18, it is given to us an object of mass 0.3 kg is thrown vertically upwards from ground with an initial velocity of 8.0 meters per second. The object reaches a maximum height of 1.9 meters. We need to find out how much work is done against air resistance as the object rises to its maximum height. So this question is simply about about conservation of energy. Means the initial energy has to be equal to final energy. Conservation of energy. Now, if you look at this object, initially this object has speed that is equal to 8.0 meters per second, and object will reach its maximum height. At this point, speed of the object will be 0. So when this object is moving up, object is gaining gravitational potential energy and object is losing kinetic energy, and object is also doing work against friction. So simply we can say the change in kinetic energy of the object, or we can say kinetic energy lost, that will be equal to change in GPE, means the gain in GPE, plus we can say work done against friction. So simply conservation of energy. Now in this case, change in kinetic energy is simply equal to 1/2 mv square. In this case, change in kinetic energy is equal to 1/2 mv square, and this one has to be equal to mg delta h plus work done against friction. This is what we need to find out. We can rearrange this one. We can say work done against friction is equal to 1/2 mv square minus mg delta h. Now simply we need to plug in values. 1/2 mv square, mass of object is given 0.3 times v, value of v is given is 8, minus we have mgh, m is 0.3, g is 9.81, and height, maximum height is given, that is 1.9. So if we calculate this value, our answer will be 9.6, and if we solve this one, our answer will be 5.6. We need to find the difference between these two. Difference will be equal to 4.02. So this is our final answer, work done against friction. So this is our final answer. But if you look at this question, there is something quite tricky about this question. You can see we have 9.6 here, and in given options you also have 9.6. We have 5.6 here. In given options you have also 5.6, but if you add these two together, this one is equal to 15. So this is also in options. So very tricky question. If you don't use conservation of energy, or you don't know how to answer in a right way, it's quite possible your guess will be wrong. So the answer for this question is A. For question number 19, it is given to us: a water pump raises a mass of 27 times 10 to 3 kgs of water through a vertical distance of 80 meters in a time of 1 hour. We need to find out what is average useful output power of the pump. So very straightforward question. Power is equal to useful work done by pump. We can simply say useful work done by pump. Work done by pump divided by time taken. So we can say divided by time taken. Useful work done by pump in this case is equal to gain in GPE. So we can say gain in GPE. Gain in GP divided by time. Gain in GP we can write down, that is equal to mg delta h over t. In this case we have value of mass, that is equal to 27 times 10 to 3 kgs. G is equal to 9.81, and height is given, that is equal to 80 meters. And time taken is 1 hour, and 1 hour has 60 minutes and 60 seconds. Now if we simplify this one, we will get our final answer, means the value of P, that will be equal to 5.9 times 10 to 3 watts. We can write down this one in kilowatts. 5.9 times 10 to 3 watts. So you can say this is equal to 5.9 kilowatts. So the answer for this question is A. I hope these questions are clear to you. If you have any question, just leave your question in comments and I will answer as soon as possible. Bye for now and see you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from October-November 2020 paper 1. In today's class, our main focus will be on waves because waves are considered to be most difficult among students at ES level. So in today's class, we will discuss waves in detail so you can have clear understanding, or at least you can have better understanding of this topic. Let's study together. Let's improve together. For question number 20, it is given to us a platform is suspended by 4 steel wires. Each wire is 5 meters long and has a diameter of 3.0 millimeters. Young's modulus of steel is given, that is equal to this. The wires obey Hooke's law when a load of mass 200 kg is placed on the platform. How far will the platform descend because of the extension of the wires? So simply in this case, we need to calculate extension of the wires. For this question, we have Young's modulus, diameter is given, length is given, and the mass is given. So we can calculate weight. We can answer this question using two different approaches. So let me explain you first of all which two approaches you can use for this problem. One way to answer this problem is you can take 4 rods together. If we take 4 rods together, they are supporting total mass that is equal to 200 kilograms. We can also take one rod because these rods are identical. So the extension in each rod is also the same. So we can also take one rod only. So the one rod is supporting 200 by 4 kgs. So we can simply say this one is equal to 50 kgs. So we have these two different approaches. In first approach, we are saying we have 4 rods and they are supporting 200 kgs. So here we have, so this is the sketch. We have 200 kgs. We need to find out extension in each rod. On the other hand, we can sketch like this. We have one rod and this rod is only supporting 50 kgs and we need to find out extension in this rod. Let's start with one rod. For one rod, we can write down Young's modulus. This is equal to stress over strain. Stress over strain. Stress is equal to F over A and strain is X over L. So we can rearrange, we can write down, in this case, we have F over X times A times L. Now, simply we need to plug in values. We need to calculate value of X. We can rearrange this. X will be equal to FL divided by E times A. So this method we are only using for one rod only. So the force on one rod will be equal to 50 times 9.81. Length of rod is given, that is 5.0. So we can write down this is equal to 5.0 and we have to divide this one by Young's modulus. Young's modulus is 2.1 times 10 to 11 and we need to multiply with cross-sectional area of one rod. We have diameter, so we can write down pi by 4 d squared. So we have d, that is 3 millimeters. So this is 10 to negative 3 square. If we solve this one, we can find out value of X. X in this case will be equal to 1.7 times 10 to negative 3 meters. So this is value of extension. So this is how we can calculate value of extension. On other hand, you can also use 4 rods together. 4 rods you can use together. So in that case, what you need to do is simply you have to multiply this one with 4 and cross-sectional area you also need to multiply with 4. So this 4 will be cancelled with this 4. So still you will get the same answer. So our answer for this question is this. This is the right answer. For question number 21, it is given to us a tensile force of 7.0 meganewtons is applied to a sample of steel. This causes the sample to extend by 5 mm in direction of force. The sample obeys Hooke's law. We need to calculate what is the work done to extend the sample. First of all, you can imagine that we have a steel rod. So imagine that this one is the steel rod. This is hanging here. And then we attach a weight of 7 meganewtons at the end of this rod. And this rod extended by 5 mm. So here we have weight, this is equal to force, and this is 7.0 times 10 to 6 newtons. And extension in this rod is given. This one is the extension. So this is extension. And value of this delta x is given. That is equal to 5.0 mm. So we need to find out work done. For this question, it is given to us the sample obey Hooke's law. So simply we can sketch graph between force and extension. So we have force on y-axis and we can sketch extension on x-axis. If we sketch the graph between these two quantities, it has to be a straight line because this sample obey Hooke's law. We need to calculate work done. So it simply means we need to calculate area under this line. So in this case, area is equal to work done. So simply we can say area is equal to work done. And this work done is equal to area of triangle. 1/2 F times X means extension delta X. Now simply we need to plug in these values. So we have 1/2 and the force is given, that is equal to 7 meganewtons. So we can say 7.0 times 10 to 6. So this is 7 meganewtons and extension is 5 millimeters. So we can say 5 times 10 to -3 meters. If we solve this one, our final answer should be 17.5 times 10 to 3 joules. But answers are given in kilojoules, so we can convert this one into kilojoules. So this will be equal to 17.5 kilojoules. So the answer for this question is C. For question number 22, it is given to us we have two waves X and Y and they have the same frequency. The amplitude of wave X is 1.5 A0 and amplitude of wave Y is 2.5 A0. The waves meet at a point and superpose to form a resultant wave. For the resultant wave, we need to find the ratio between maximum possible intensity and minimum possible intensity. Maximum possible intensity we will get when waves interfere constructively. So we can simply say when constructive interference will take place, intensity will be maximum. Constructive interference. And intensity will be minimum when destructive interference will take place. Destructive interference. So very simple way to understand this one. Maximum and minimum intensity. Now we can draw two waves. First of all, we can draw wave X. So we will only draw one pulse. So it will be easy to see what is happening. Imagine that this is wave X. This is pulse of wave X. And this is moving to the right. Amplitude of this wave is given. So this is the amplitude. And this one is equal to 1.5 A0. We can also draw another wave, wave Y. Let's say this is pulse of wave Y. And this wave Y, we can imagine that this is moving to the left. Amplitude of this wave is also given. Amplitude of this wave is AY, that is equal to 2.5 A0. Now let's try to understand when these interfere constructively. So what is the amplitude of resultant wave? So first of all, we will draw for constructive interference. Constructive interference. Constructive interference. So for constructive interference, we have wave X and we have wave Y. Y is moving to the left. So we have these two waves. So this one is X and this one is Y. At this point, they will interfere with each other. So when they will interfere constructively. So we will get a super crest. So we will get super crest like this. Means simply we need to add these two waves together. So this is the super crest we will get when these two waves will interfere. And the amplitude of this super crest will be equal to amplitude of X plus amplitude of Y. So the final value of amplitude we will get 2.5 A0 plus 1.5 A0, that will be equal to 4.0 A0. Now we can repeat the same process for destructive interference. Destructive interference. means when the waves cancel each other. In this case, we have wave X. Let's say this is the crest of wave X. This is moving to the right. So this one is wave X. This is moving to the right. And we have trough of wave Y that is moving to the left. So this is wave Y. Let's say they interfere at this point. So in this case, the amplitude of this one is negative. So this is negative 2.5 A naught. Then this one is 1.5 A naught. So when they will interfere at this point, they will cancel each other. So we will get minimum value of amplitude. So in this case, we have 2.5. So we can just subtract 2.5 A naught minus, we can take 1.5 A naught. So this one will be equal to A naught. We can clean little bit and we can redraw. So here, so this one is the resultant. So let me use different color and write on here. So this is over resultant wave and this is also resultant wave. This is amplitude of resultant wave and this is also amplitude of resultant wave. Now we need to understand the relationship between intensity and amplitude. Intensity is directly proportional to amplitude square. Or simply we can say intensity over A square. This is equal to constant. So we can write down this is equal to constant. For the maximum we can say I max over A max. We can say this one is A max. A max square has to be equal to I min. So I minimum divided by A minimum means this value A minimum. We can also write down here. So this one is A minimum and this one is A max. A max. So this is A minimum square. Now we need to rearrange this. So we can write down I max divided by I min. This will be equal to A max square divided by A min square. Now we can plug in values. A maximum is equal to 4 A naught and A min is A naught square of this. Now if we solve this one, we will get 4 by 1. In this case, this is 16. So we will get this is 4 square by 1 means we will get 16 by 1. A square will be cancelled with A square. So we left with 16 by 1. So the answer for this question is 16. So this square is very important. If you miss this one, maybe you will tick on C. So square is very important. We can also write down here this is 16 A square, A naught square, and this one is A naught square. So the A naught is cancelled with A naught. So the answer is D for this question. For question number 23, it is given to us the displacement time graph for an 8 particle in the path of a sound wave is shown. We need to find out which property of the sound wave must be increasing. So this is very important. But if you look at this given graph, you can see on y-axis we have displacement and on x-axis we have time. In this case, amplitude of the wave is not decreasing, means it's not changing. So simply we can say amplitude of wave is constant. But if you look at time period, so this is t1 we can say, and here time taken from here to here, this is t2. In this case, t2 is smaller than t1. It means that time period of the wave is decreasing. Time period of the wave is decreasing, but we need to find out which property is increasing. But if you look at the relationship between time period and frequency, time period is equal to 1 over frequency. If the time period is decreasing, it means that frequency must be increasing. We can also write down this one. Frequency is equal to 1 over t. If time period is decreasing, it means frequency is increasing. Let's try to understand a little bit more about this one. We have already discussed, in this case, frequency is increasing. As frequency is increasing, it means that frequency of source is changing. So we can say frequency of source is changing, or we can say frequency of source is increasing. It means source is sending waves with different frequencies, and the frequency of the sound waves is increasing. So source is sending sound waves every time, but with different frequencies, with increasing frequency. Now if you look at the speed of the wave, that is equal to v times times f lambda. Speed of the wave, this depends on medium. Speed of a wave, it depends on medium, and it depends on type of wave. But in this case, we have sound wave, so we have the same type of wave and they are in the same medium. So it simply means that frequency, if this frequency is increasing but speed is the same, so the lambda of the waves, coming waves, has to decrease. So source is producing sound waves with different frequencies, means with increasing frequency. So the lambda of the coming waves has to decrease. So simply this is what you can understand from this one. I mean how this is produced. Question is asking us to find out which property of the sound must be increasing. Amplitude is not changing, but frequency is increasing. So this one is the right answer. Period is decreasing. So this is not right answer. If we assume in the same medium, so speed is constant. So this is also not correct option. So this is also not. So the answer for this question is A. For question number 24, it is given to us a sound wave is displayed on the screen of CRO as shown in this figure. This is a typical type of question. Every year you will see one question about CRO. So the understanding of CRO is very important for paper 1. For this question, it is also given to us that time base of the CRO is set at 2.5 milliseconds per centimeter. We need to find out what is frequency of the sound wave. If you look at time period of this, in this case, you can see this is one wave from here to here. So this one is one wave. So this is half time period and this is one time period. And if you look at this one, in this case, we have 4 centimeters. Means we have 4 small boxes. We have 4 small boxes, mean we have 4 centimeters. In this case, we can say time period is equal to 4 small boxes, and this is equal to 4 centimeters. We need to find out time period. It is given to us that 1 centimeter is equal to 2.5 milliseconds. We have 4 centimeters. We need to find time period. So we have to multiply this one with 2.5 milliseconds per centimeters. So we can cancel centimeter with centimeter. So in this case, we can find out value of time period. That is equal to 4 times 2.5 millisecond. We need to find the frequency of this wave. So frequency will be equal to 1 over t. So simply we can write down in this case 1 over 4 times 2.5 milliseconds. So this is 10 to negative 3. Now if we solve this one, frequency will be equal to 100 hertz, and that is value of frequency. So simply we can say in this case frequency is equal to 100 hertz. So this one is the right answer. So this is how you can approach this type of problems. For question number 25, it is given to us the horn of a train emits sound of frequency f1. While the horn is sounding, the train moves directly towards a stationary person. The speed of the train is 0.20 v. V is the speed of sound. The frequency of the sound heard by the person is f2. We need to find out what is the ratio of f1 over f2. First of all, let's get this one. So this one is the train. For this train, we have the speed of this train. This train is moving with speed 0.20 v. And the frequency produced by this train is f1. And this is equal to frequency of the source. Observer is standing in front of this train and observer is at rest. We can say speed of observer is equal to 0. For this question, it is also given to us the frequency of the sound heard by this observer is f2. So we can say this is frequency of sound observed by this observer. Now simply we need to use Doppler effect. In this case, source is approaching. So we have to use Doppler effect when source is approaching. So this is the point you need to understand. In this case, is the source is approaching or is the source is moving away? In this case, source is approaching. As the source is approaching, we can write down observed frequency. This one will be equal to speed of the wave over speed of the wave minus speed of the source times frequency of the source. Now we can rearrange this one. We can write down F naught by Fs. This will be equal to V over V minus Vs. Now simply we need to plug in values. F naught, observed frequency, F naught, this is equal to F2, and Fs, this is equal to F1. And this is equal to V over speed of the wave is V. So we can say this is V. V over V minus speed of the source is 0.20 V. Now just we need to simplify. In this case we can write down F2 over F1. This is equal to V over, we can take common V from here, so this is 1 minus 0.20. So simply we can cancel this V with this V. So we left with 1 over 0.80. We need to find out F1 by F2. So this is F2 by F1. So we can write down F1 over F2. This will be equal to 0.80 divided by 1. So this is our final answer. This is what question was asking us to calculate. So the answer for this question is 8. For this question, you have to be careful. It's a little bit tricky one. Maybe some student, they will just tick this. But this is wrong option. This is F2 over F1. Question is asking us to calculate F1 over F2. So just be careful with this. For question number 26, it is given to us two satellites are in orbit around the Earth at a constant distance of 100 kilometers apart from each other. Satellite X transmits a microwave pulse towards satellite Y. The pulse takes time t to reach Y. Satellite Y then transmits a pulse of visible light towards satellite X. What is the time taken for the pulse of light to reach X? So first of all, simply we can imagine that there are two satellites. So we can say this is satellite X and we have an other satellite here at a distance of 100 kilometers. Distance between these two satellites is given. Distance is equal to 100 kilometers. We can say D is the distance. Satellite X transmits microwaves. So this transmits microwaves. So we can write down here satellite X transmits microwaves. And the time taken for microwaves to reach Y is T. Time taken is T, we can say, for microwaves to travel from X to Y. We need to find out the time taken by visible light that is transmitted by satellite Y, visible light. So simply we can write down here visible light. We need to find out how long this will take, means the time taken by visible light to reach X. So this time we need to find out. Let's try to understand about speed of wave. Speed of wave, it depends on two factors. One, it depends on medium. If the medium is different, speed of the wave will be different. And speed of the wave also depends on type of wave. Type of wave means different waves in the same medium, the speed is different. If you look at these two waves, means the microwaves and visible light, they belong to electromagnetic waves. It means they belong to same type of waves because this is electromagnetic wave and visible light also belongs to electromagnetic waves. So they are same type of waves. As they are same type of wave and they are in the same medium, it means the speed of the visible light, we can say the speed of visible light is equal to speed of microwaves. Because they are same type of waves, they are electromagnetic waves and they are in the same medium, so they have the same speed. Now if you look at distance, distance is equal to speed times time. Speed times time. Now from here we can say time will be equal to distance over v. Distance is the same. So if the speed is also the same, it means time taken is the same. So the answer for this question is T. So the visible light also will take time capital T to travel from Y to X. For question number 27, it is given to us a stationary wave is formed on a stretched string. The diagram illustrates the string at an instant of time when the displacement of the string is at its maximum. The frequency of the wave is given, that is equal to 250 Hertz. Point P on the string has a vertical displacement of negative 1.0 mm. What will be the vertical displacement of the point P after a time of 5.0 milliseconds? How we can approach this problem? So the first thing you need to understand, in this case, it is given to us this point is at the lowest point, and the amplitude of this one is equal to 1.0 mm, and frequency of this wave is given. So we have the frequency, so we can start from frequency. Frequency in this case is equal to 250 Hertz. So we can calculate time period of the wave. Time period will be equal to 1 over frequency. So we have 1 over 250 Hertz. So if we calculate value of time period will be equal to 4 milliseconds. 4 milliseconds means that wave will complete one cycle and time taken is equal to 4 milliseconds. Mean if this point start from here and when it come back to this point, time taken will be equal to 4 milliseconds. Now let's try to do this question step by step. We have to find out displacement after a time of 5.0 milliseconds. So if this particle move from lowest point to this point, time taken is equal to 1 millisecond. And then when it goes to the highest position, again it will take 1 millisecond. And then it will start coming down. So when it will come from this highest to the equilibrium, it will take another 1 millisecond. And then when it will move from equilibrium to the lowest point, means to this point again, it will take another 1 millisecond. So 4 milliseconds have passed. 4 milliseconds. We still have 1 more millisecond. So for that one, we will be using different color. So this will go up again. So it will take again 1 millisecond to move from the lowest point to equilibrium. So it will take 1 more millisecond. So after 5 milliseconds, this particle, it will be at this point. The vertical displacement of point P will be equal to 0 because this is at rest position. So vertical displacement of this one is equal to 0. You can also understand this one. Particles start from this point, it will go up, and when it come back to this point, it will take 4 milliseconds. And then it will go up. It will reach this point. It will take 1 more millisecond. So the vertical displacement at this point will be equal to 0. So the answer is B. For question number 28, we need to find out what is meant by diffraction. If you look at option A, it is given to us the change in observed frequency when a source moves relative to an observer. And this is Doppler effect, means the change in observed frequency. So this is Doppler effect. This is not diffraction. The formation of nodes and antinodes by two progressive waves traveling in opposite directions. And this is telling us about standing waves. So this is description of standing waves. If you look at option C, it is given to us the spreading of a wave around the edge of an obstacle. And this is diffraction. So this one is diffraction. So our answer for this question is C. So C is the right answer. If you look at option D, it is given to us the superposition of two waves when they meet. This is about interference of waves. So we can say this is about interference. So the answer for this question is C. For question number 29, it is given to us in a dark room, a small source of red light illuminates two slits, and the distance between two slits is given, that is equal to 0.75 mm. A few meters beyond the slits, the light falls on a screen, producing a series of equally spaced bright lines. We need to find out which change would cause the distance between the bright lines on the screen to reduce. So first thing we need to understand is this question is about Young's double slit or is it about diffraction grating? If you look at statement of this question, it is given to us two slits. So it is about Young's double slit experiment. So in this case, we have slits, so we can simply draw here. We have two slits, and the source of light, we can imagine that the source of light is here. So this one is source of light. We can say this is S, and screen is placed here. So this one is screen. It is given to us the distance between screen is few meters beyond. A few meters beyond the slits, light falls. So distance between slits and the screen, few meters. But the distance between these two slits is given. We can say that distance is equal to d. Let's say this distance is small, and this is equal to 0.75 mm. This is source of red light, so we can also say this is red light. We need to find out when the separation between the fringes, so these are the fringes, so these are bright fringes. So simply we can draw these are bright fringes, and the distance between these fringes, two consecutive bright fringes, let's say that distance is equal to x, and the distance between slits and screen, let's say, is equal to capital T. Now let's try to write down formula for Young's double slit experiment, and formula is dx is equal to lambda times d. In some books they use a instead of d. So simply you need to understand a or d. This is the distance between the slits, or you can say slit separation. If we rearrange this one, we can write down x is equal to lambda times capital D divided by d. Now if you look at option A, it is given to us change the source for one emitting blue light. Lambda of the blue light is smaller than lambda of red light, so we can write down here red light. Now if lambda go down, means lambda decrease, it means x will decrease. If we keep d same and capital D same, so it means x will decrease, and this is what we need to find out. So the answer for this question is A. Now let's move on to option B now. For option B, it is given to us reduce the distance between the source and the slits, means reduce this distance. Let's say this distance is S1. Question is asking us to reduce this one. If we reduce this one, there will be no effect because there is no distance between source and the slits in this equation. So it means no effect. If we change the distance between source and the slits, it will have no effect on fringe spacing. X is fringe spacing. So simply we can also write down here X is fringe spacing, mean the separation between bright fringes. It will not change. But if we reduce this distance or we increase this distance, mean S, if we increase or if we decrease, it will have effect on brightness of bright fringes. So this is also we need to understand. Now if we go to part C, it is given to us reduce the distance between the slits to 0.5 mm. Now this is telling us we reduce D. If we reduce D, it means X will increase. So this is not answer because we need to find out when X will decrease, mean X will be reduced. So that's reason C is not right answer. Reduce the intensity of the light source. It will affect the brightness of bright fringes, but it will not affect fringe spacing. So D is also not possible answer. B is also wrong. So the answer for this question is A. For question number 30, it is given to us light of wavelength 5.3 times 10 to negative 7 meter is incident normally on a diffraction grating. The first order maximum is observed at an angle of 15.4 degrees to direction of the incident light. We need to find out what is the angle between the first order and the second order diffraction maximum. So first thing we need to understand, this question is about diffraction grating. So we can draw diffraction grating here. So this is diffraction grating, and we can imagine this is the light. So light is coming from here, and we have screening here, and at the center we have center bright fringe. So n for this one is equal to 0, and the first fringe we observe here. So this one is the first, and we have the second one observed here. This is n is equal to 1. This one we can say n is equal to 2. For this question, it is given to us the angle of first order maximum. This angle is given, so we can say this is theta 1. Value of this one is given, that is equal to 15.4 degrees. Question is asking us to find out angle between these two. Means this angle question is asking us to find. So this is what we need to find. First of all, we can find out angle of second order. Means we can find angle of second order maxima. We can find out this angle theta 2. Then we can find out the difference between these two, that will be equal to theta. So first of all, we can say theta, or you can say delta theta. This will be equal to theta 2 minus theta 1. Second order and first order. Now first of all, we need to find out theta 2. We can write down for n is equal to 1. For n is equal to 1, we have d sine theta. Means this is equation for diffraction grating. D sine theta is equal to n times lambda. But n is equal to 1, so we can say this is d sine theta, and this one is equal to lambda. We can say this is equation 1. We can also write down for second order, means when n is equal to 2. We can write down d sine of theta. This is equal to 2 times lambda. And this is theta 1 and this is 2. So we can say this is over second equation. But value of theta 1 is given. So we can rewrite here. So we can write down d sine of 15.4 degrees. This is equal to lambda. We can say this is over third equation. Now if we divide 2 by 3, we can calculate value of theta. So in this case, we can write down d sine theta 2. This is equal to 2 times lambda, and this is divided by d sine of 15.4 degrees, and this is equal to lambda. Now we can cancel this lambda with lambda, and d we can cancel with d. We need to find out theta 2, so we can say sine theta 2 in this case will be equal to 2 times sine of 15.4 degrees. 15.4 degrees. From here we can find out value of theta 2. This one will be equal to sine inverse of 2 sine of 15.4 degrees. Now if we solve this one, we will get value of theta for the second order, and this one will be equal to 32.1 degrees. So we have value of theta 2. So this is theta 2. We need to find out the difference between these two. So we can write out here 32.1 minus we have 15.4 degrees. If we solve this, our final answer will be 16.7 degrees. So this is our final answer, and this is the angle between first order and second order. Means this angle, we have found value of this angle. So the answer for this question is C, 16.7 degrees. Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on electricity and radioactivity from October-November 2020 paper 1. For question number 31, it is given to us a stationary particle is in electric field. The only force acting on the particle is from the electric field. In which case is the electric field, means the capital E is equal to 5.0 times 10 to 5. But if you look at options, for each option the force on the particle is given and type of particle is also given. So this is true for all options. You can see force is given, particle is given. For C, force is given and particle is given. Again, force is given and type of particle in the field is also given. Now the first thing we need to understand is that what is the relationship between force and electric field? Electric field, simply E is equal to the force on the particle divided by charge on particle. So Q is the charge on particle. So simply we have to use E is equal to F over Q, and we need to calculate value of E for all these options. So for option number A, E is equal to F over Q. So F is given, that is equal to 1.6 times 10 to negative 14. And the charge on electron is 1.6 times 10 to negative 19. If we solve this one, simply we can cancel 1.6 with 1.6. Our final answer will be 1.0 times 10 to 5 volts per meter. So this is not what we are looking for. I mean, this is not correct option. Our answer has to be 5.0 times 10 to 5. So A is not answer. Now, if you look at B now, so I will be writing here for B, E is equal to F over Q. So the force acting on the particle is given, that is 3.2 times 10 to negative 14. We have to divide this one by the charge on particle. In this case, our particle is alpha particle. So the charge on alpha particle is 2 times the charge on electron. So we can say this is 1.6 times 10 to negative 19. So in this case, 3.2 we can cancel with 2 times 1.6. Our final answer in this case is also equal to 1.0 times 10 to 5 volts per meter. So this is also not correct option. So we can cancel this one. Now if you go to part C, for option C, it is given to us. E is equal to, the force on the particle is given, that is 8.0 times 10 to negative 14 divided by charge on alpha particle. So charge on alpha particle is 2 times the charge on single electron. Now if we solve this one, in this case our final answer will be 2.5 times 10 to 5 volts per meter, and this is also not correct option, so we can also cancel this one. Now if we go to our final option D, it should be the answer. E is equal to F over Q. Force in this case is given 8.0 times 10 to negative 14, and particle is proton, and the charge on proton is equal to the charge on electron. So this is 1.6 times 10 to negative 19. If we solve this one, 8 divided by 1.6, we will get 5.0 here. So we can say this is 5.0 times 10 to 5 volts per meter. So our best possible answer for this question is D. So D is the answer. Concept you need to understand is E is equal to F over Q, and Q is charge on particle in the field. So this is charge on particle in the field. So we can simply say in the field. Charge on particle in the field. And F is the force here. For question number 32, it is given to us a constant potential difference is applied between two horizontal metal plates. A charged oil droplet is held stationary, means is at rest by the electric field between the two plates. It is also given to us as some of the oil evaporates, the droplet loses mass and starts to accelerate. Its charge remains constant. We need to find out in which direction does the droplet accelerate and which change needs to be made to the separation of the plates in order to stop this acceleration. For this question, it is given to us particle is stationary, means the droplet is stationary. It simply means that its velocity is equal to 0. As velocity is equal to 0, it simply means that forces acting on this droplet are balanced. Or simply we can say F net on this droplet, or which simply we can say particle is equal to 0. Now we need to understand what kind of forces are acting on this droplet. The one force acting on this droplet is weight of this droplet, because it has mass, so weight is acting on this particle. Weight means force of gravity is acting on this particle, and force of gravity is always downwards. So this is direction of force of gravity on this droplet. This droplet has charge and this droplet is inside electric field. So the electric force has to act upwards. Then resultant force on this particle will be equal to 0. So this is direction of electrical force, Fe. Fe is equal to Eq, means the electrical force is equal to Eq. It is also given to us that some of the oil evaporates, droplet loses mass. If the mass of the droplet decrease, it means weight will decrease. So we can redraw this diagram, free body diagram. So weight decreases, so W decreases, but it is given to us its charge remains constant. As Q remains constant, E is also constant. It means electrical force remains constant. So in this case, electrical force is greater than weight now. As electrical force is greater than weight, it simply means that particle will accelerate upward because the resultant force is upward. So in this case, resultant force is upward, so acceleration is also upward because acceleration and resultant force always in same direction. So first question was, in which direction droplet accelerates? So droplet will accelerate upwards. Now let's move on to second part. Question is asking us which change needs to be made to the separation of the plates to stop this acceleration. We need to stop this acceleration. It simply means that we need to make resultant force equal to 0. But if you look at electrical force now, Fe, this is equal to Eq. But E is equal to delta V, means the potential difference between plates divided by separation of the plates, means the separation between plates. Now if you want to decrease electrical force, question is asking you what change needs to be made to the separation of the plates. So if we increase separation, mean if we increase D, then electrical force will decrease. So simply we need to say that we need to increase separation. So there are 2 points. First thing, acceleration has to be upwards. The second, we need to increase the separation. So if you look at option D, you can see it is given to us. Acceleration is upwards and separation has to increase. So D is the right answer for this question. For this question, it is given to us two resistors R1 and R2 are made from wire of the same material. If material is the same, it means the number density is the same. So the number density for resistor 1 and for resistor 2 is the same. So we can say N is same. It is also given to us these resistors are connected in parallel to each other in a circuit as shown. So as you can see here, we have two resistors R1 and R2. Diameter of R2 is half the diameter of R1. From here we can say cross-sectional area of resistor 1. This has to be equal to 4 times the cross-sectional area of resistor 2. So simply we can say A1 is equal to 4 times of A2 because D1 is equal to 2 times of D2. And area is equal to, means the cross-sectional area, this is equal to pi by 4 D squared. So if D is double, it means area is 4 times. So that's the reason we have written A1 is equal to 4 times of A2. It is also given to us resistance of R2 is 3 times the resistance of R1. Resistance of R2 is 3 times of the resistance of R1. So R2 is equal to 3 times of R1. But if you look at these two resistors, they are connected in parallel. So it means V2 means the potential difference across the second resistor is equal to potential difference across first resistor. But for second resistor V2, we can simply write down this is I2 times R2 is equal to I1 times R1. But R2 is equal to 3 times of R1 and this is equal to I1 times R1. So this is I2. From here we can find out that I1 is equal to R1. R1 we can simply cancel. So the I1 is equal to 3 times of I2. So this information we can get from the given resistance. For this question, we need to find the ratio between drift speed of free electrons in R1 and in R2. So we need transport equation. According to transport equation, I is simply equal to NQVA. We can rearrange this one. We can say I over VA. This is equal to NQ. But NQ is constant for wire 1 and it is also constant for wire 2. Simply we can say it is equal to constant. We can write down then I over means I1 over V1 A1. This is equal to I2 divided by V2 times A2. We can cross multiply, so means we can multiply this side with I1 and we can multiply this one with I2. So we can write down I1 V2 times A2. This is equal to I2 times V1 times A1. We need ratio between V1 and V2. So we can divide this side by I2 V2 times A1. So we also need to divide this side by I2 times V2 times A1. Now we can simply cancel. On this side, we can cancel I2 with I2. We can cancel A1 with A1. And here we can cancel V2 with V2. So we simply left with V1 over V2. This is equal to I1 times A2 divided by I2 times A1. Now, if you look at value of I1 is equal to 3 times I2. So we can write down here I1 is equal to 3 times I2. If we write down value of A1, so we just write down A2 here. So we can plug in value of A1. A1 is equal to 4 times A2. So we can say this is 4 times A2. Now simply we can cancel I2 with I2 and A2 we can cancel with A2. So simply we left with 3 by 4. And this is the ratio between V1 and V2. So our answer for this question is B. For question number 34, it is given to us a student describes potential difference as the energy transfer per unit charge. Which statement about the energy transfer is correct? First of all, let's try to understand what is the difference between potential difference and EMF. EMF simply we can say this is amount of chemical energy or you can say other forms of energy. Amount of other forms of energy converted into electrical per unit charge. Chemical or you can say other forms. So we can write down here other forms of energy converted into electrical energy per unit charge. So this is how we can define EMF. Chemical to electrical energy per unit charge, that is called EMF. For potential difference, this is just reverse. We can say electrical energy converted into other forms of energy. So we can say electrical energy converted into other forms of energy per unit charge. Other forms of energy per unit charge. So that is what we call potential difference per unit charge. Now if you look at options, it is given to us, it is from electrical energy into other forms. So this energy transfer is true. So this is potential difference. So this is our answer. If you look at option B, it is from other forms into electrical. So this one is wrong actually. This is about EMF. So option B is not correct. If you look at option C now, it is given to us it only takes place inside a power supply. But this energy transfer means electrical energy can be converted into other forms in other devices as well. Means this energy transfer also can take place inside resistors. It also can take place inside motors and so on. So option C is incorrect. It is saying only. But this energy transfer means electrical energy can be converted into other forms in other devices as well, not only in power supply. But if you look at option D, it is also given to us it only takes place inside resistors, but it can also take place inside power supplies. When due to internal resistance, electrical energy can be converted into other forms. It also can take place inside motors and other devices as well. So this is also not right. This is incorrect. It is saying only. So this one is wrong. So option D is also incorrect. So our answer for this question is A. For question number 35, it is given to us a metal cube has a resistance of 4 ohms between opposite faces. 10 of these cubes are put together to make a cuboid of 1 by 2 by 5 cubes, as you can see here. So this one is the cuboid. There is no extra resistance when the faces of the cubes touch each other. What is the resistance of the cuboid when connected between faces X and Y? Means if we connect power supply here across faces X and Y, what is the resistance of this cuboid? First thing we need to understand, if we look at these cubes, so this is first cube, this one is the second one, third, fourth, and fifth. This one is the 6, 7, 8, 9, 10. If you look at these 5 cubes, they are connected end to end. It means these 5 cubes, they are connected in series, and these 5 cubes, they are connected in series. So simply we can redraw this circuit. So we can connect these cubes, we can treat them as resistors. So the first row, we have 5 cubes connected in series, or we can say 5 resistors connected in series. And in the second row, we have 5 cubes connected in series. It simply means that we have 5 resistors and they are connected in series. So this is how we can redraw the circuit. So this is our point X and this is our point Y. Between X and Y, power supply is connected. So here we can connect power supply. Now each cube has a resistance equal to 4 ohms. So we have 5 cubes connected in series. It means the total resistance of 5 resistors or 5 cubes, this is equal to 20 ohms. And the total resistance of 5 cubes in the second row is also equal to 20 ohms. Now simply we need to find out the total resistance of these two resistors. So this is our point X and this is point Y. So these are two identical resistors. So we can say total resistance is equal to product of these two resistors divided by sum of their resistance. So 20 plus 20. Now if we solve this one, in this case we'll get this is 400, 20 by 20 means 400 divided by 40. So 20 plus 20 is 40. So our final answer in this case is simply equal to 10. Or simply, if you look at these two resistors, they are identical and they are connected in parallel. It simply means that the total resistance is equal to the resistance of one resistor divided by number of resistors. So one resistor resistance is 20 and we have only two resistors. So it means the total resistance of these two resistors is equal to 10 ohms. So that's the reason our answer for this question is C. For question number 36, it is given to us a cell is connected to a fixed resistor. Over a long period of time, the internal resistance of the cell increases. What is the effect of the increase in internal resistance on the electromotive force of the cell and on the power dissipated by the fixed resistor? First of all, let's try to sketch this circuit. So in this case, you can imagine that this is our battery and this battery has internal resistance. We can say EMF of this cell is E. And there is another resistor is connected, that is external resistor. And the resistance of external resistor is fixed. We can say the resistance of external resistor is capital R. So this is our cell actually. If you look at the cell, so this is cell and the internal resistance of this cell is small r. Now if R increase, it has no effect on EMF. So this is the first thing we need to understand. If R increase, EMF does not change. So this is the first point you need to understand. EMF does not change. If R increase and EMF does not change, then we can find current in this circuit. So current is equal to EMF over total resistance. Now if R increase, it means I will decrease. If I decrease, then the power dissipated by this resistor, we can write down P power dissipated by R. This will be equal to I square times R. As the resistance of external resistor is fixed. So if I decrease, it means power dissipated by external resistor, this will decrease. So these are the points you need. First point, EMF does not change with increase in internal resistance. The second point, power dissipated by the fixed resistor, this will decrease. So the answer for this question is C. So you can see EMF no change. Power dissipated decreases. So the answer is C. For question number 37, it is given to us four identical resistors are connected in a circuit as shown in this figure. It is also given to us that battery has negligible internal resistance and EMF of the battery is equal to 30 volts. We need to find the potential difference between 2 points X and Y. It simply means that if we connect a voltmeter between X and Y, so what is the reading on this voltmeter? So this is what question is asking us to find out. So first of all, let's try to write down the given resistance. Let's say the resistance of this resistor is capital R, so the resistance of this one is also capital R. Resistance of this resistor is capital R and resistance of this resistor is also capital R because all these resistors are identical. Now these two resistors we can replace with one resistor and these two we can replace with one resistor. These two resistors are connected in series, so it means the total resistance of these two resistors is equal to 2R, and these two resistors, they are connected in parallel, so the total resistance of these two resistors is equal to R by 2. So we can redraw this circuit. So let's redraw this. So this is our battery, so simply we can draw this one is the battery, and the EMF of this battery is given, that is equal to 30 volts. So this one is our battery. You can also draw like this. So it means this one is battery. It has many cells connected in series. So these two resistors we can replace with one resistor of resistance 2R, and these two we can replace with one resistor of resistance R by 2 because these two resistors are connected in parallel. Now we need to find out current in the circuit. So current in the circuit will be equal to EMF of the cell divided by total resistance. So the total resistance of this circuit, simply we can write down, this is 2.5 times R. We need to find out the potential difference across this resistor. Means our voltmeter is connected between these 2 points. This is our point X and this is our point Y. So we need to find out what is potential difference between X and Y. So the potential difference between X and Y is equal to current times the resistance. So we can say 2R. From here we can write down I is given. This is 30 divided by 2.5R and this is multiplied with 2R. Now simply we can cancel this R with R. So we left with 30 multiplied by 2 divided by 2.5. Now if we solve this one, our final answer will be 24 volts. So answer for this question is 24 volts. Means the reading on this voltmeter will be equal to 24 volts. For question number 38, it is given to us a power supply and a solar cell are compared using the potentiometer circuit as shown in this figure. For this circuit, it is given to us the potentiometer wire PQ is 100 centimeters long and the resistance of the wire is 5 ohms. So simply we can write down here first of all, resistance of wire PQ is equal to 5.0 ohms. The power supply has an EMF of 2.0 volts and solar cell has EMF of 5.0 millivolts. We need to find out which resistance must be used so that galvanometer reads 0 when PS is equal to 40 centimeters. Now let's try to answer this one step by step. So first of all, we need to find out the potential difference across PQ. So we need to find out potential difference across PQ. But we need to understand the potential difference across PS. This is equal to 5.0 millivolts when galvanometer reading is equal to 0. So this is the first point we need to understand. So we can simply say that in this case VPS, this is equal to 5.0 millivolts, and the length of PS is also given, that is equal to 40 centimeters, and the length of PQ is given, that is equal to 100 centimeters. So we can find out the potential difference across PQ. So this is our main goal now. First of all, we need to find out the potential difference between P and Q. So we will start from I, current. Current passing through PS and PQ is the same because it is the same wire, and there is no current passing through the solar cell. So we can say IPS, this is equal to IPQ. So this is the main concept. Now we can say that the potential difference across PS divided by the resistance of PS means RPS. This has to be equal to the potential difference across PQ divided by the resistance of PQ. In this case, we are talking about PS and PQ. We are talking about the same wire. For the same wire, resistance is equal to rho L by A. As the wire is the same, it means rho is the same and A is the same. So resistance is simply depending on L. So we can replace resistance with L. So we can say VPS over LPS. This is equal to VPQ over LPQ. So this is LPQ. So we can replace RPQ with LPQ because we have the value of L. So VPS is 5 millivolt. So I will write down here, this is 5 millivolt. So this is 10 to negative 3 divided by the length of this one. So this is 40 centimeters. Simply we can say this is 0.4 meters. VPQ we need to find out. So this is VPQ divided by length of PQ 100 centimeters. So simply this is 1 meter. From here we can find out VPQ. So if we solve this one, so VPQ simply will be equal to 0.0125 volt. So this is value of VPQ. Now we have value of VPQ, so we can find out the potential difference across R. So I will say VR. So we can find out the potential difference across the resistor R. So VR simply will be equal to the potential difference across this R. We can simply say this will be equal to EMF minus potential difference across PQ. EMF is 2.0 volts, so we can subtract 0.0125. This is the PD across PQ. So it simply means that EMF is equal to VR plus VPQ, if you're not very clear about this. So this is what we are using. We're using this concept. So now from here we can find out VR. So the potential difference across resistor R is 1.9875 volts. So this is value of potential difference across this resistor. Now we need to find out current. So how we can find out current? So I we need to find out. As this resistor and PQ, they are connected in series, it means current passing through this wire is the same as current passing through R. So we can say if current I is here, current I also will be here, and current I is also here. Current is the same because they are connected in series, and there is no current passing through this solar cell. So I we can find out. So we have this resistor, means we have this wire, we have potential difference across the wire. So I will say this is I for the wire. Potential difference across wire we have found, that is VPQ, and the value is 0.0125, means this value. This is the potential difference across wire, and the resistance of the wire is 5 ohms. So this is given to us 5 ohms. So simply we can divide by 5 this. If we divide this one by 5, so value of I will be equal to 0.0025 amps. So this is value of current. And we have potential difference across this resistor. So simply we can find out the resistor, this will be equal to, mean the resistance of resistor R will be equal to potential difference across resistor R divided by current passing through resistor R. So VR we have, this is value of VR, and this is 1.9875. We need to divide by current. So this is 0.00 means 0025. If we solve this, our final answer is 795 ohms, and this is the value of resistance of resistor. So the answer for this question is C. This is the answer. Very nice question about potentiometer. For question number 39, it is given to us the table contains data for 4 different nuclei. P, Q, R, and S. We need to find out which 2 nuclei are isotopes of the same element. So the first thing we need to understand, isotopes of the same element have same number of protons. Means isotopes of any element, they have same number of protons. So this is the key concept we need. They have same number of protons. If you look at this table, we have nucleon number and we have number of neutrons. So we also need to understand how we can find out number of protons. So simply we can write on here how we can find number of protons. Number of protons is equal to nucleon number. So I will say simply nucleon number minus neutron number, means the number of neutrons. So here we have neutron number. Now if you look at nucleus P, for this nucleus we have nucleon number 10 and number of neutrons means neutron number is 5. So the proton number means P is the number of protons. Simply this is equal to 5, means 10 minus 5. If you look at nucleus Q, it is given to us, it has 10 number of nucleons and neutron number is 6. So the proton number is 4, means 10 minus 6. If we go to nucleus R, we have total 14 nucleons and neutron number is 6. So the proton number is 8, means it has 8 protons. But if we go to nucleus S, we have 16 nucleons and neutron number is 8. So the number of protons are 8. Isotope has same number of protons. So it means R and S, they have same number of protons. So these are isotopes of the same element. So our answer is D. For question number 40, we need to find out which particle is a fundamental particle. Fundamental particle simply means that it cannot be further subdivided. So simply we can say it cannot be further subdivided. Or we can simply say it does not consist of smaller particle. So we can say not consist of smaller particle. So another way to say this one, we can say not consist of smaller particles, and that particle we call is fundamental particle. Now we need to find out which particle is the fundamental particle. First one is alpha particle. This is not fundamental particle because it consists of protons and it consists of neutrons. And neutron and protons, they consist of quarks. So this is not fundamental particle. If you look at electron, electron is fundamental particle. So our answer for this question is B, because electron does not consist of smaller particle. So electron is fundamental particle. We cannot divide this one into smaller particles. So this is fundamental particle. So electron is fundamental particle. So this is fundamental particle. Neutrinos are also fundamental particles. Another example of fundamental particle is neutrino. So we can also write down neutrino. Neutrino is also fundamental particle. If you look at neutron, neutron is also not fundamental particle because it consists of quarks. Neutron has 1 up quark and 2 down quark. So it consists of smaller particles. So it is not fundamental particle. Proton also consists of quarks. Proton consists of 2 up quark and 1 down quark. So it consists of 2 up quarks and 1 down quark. So it consists of smaller particles. So proton is also not fundamental particle. So fundamental particle simply means that it does not consist of smaller particles, or simply we can say we cannot divide this one into smaller particles.